Hello everyone, this is the first lesson recording for IM2, May 17th, 2021. So from now until you're freed, till the end of school, we only have 4 classes remaining. So we're going to be covering 3-dimension solids, 3D solids, and review critical concepts needed for you to be successful in IM3. The final will include everything from this semester, including what we are learning currently, 3D solids, and critical concept needed for IM3. And the things to help your grades, and I am going to be accepting till May 28th, not beyond that. Okay? Any missed quiz or quiz retakes, if you haven't done so already, and test corrections for Unit 6 and 7 or Unit 9 will also be available. But remember, you only get 25% of missed points, even if your work, your test correction work is good, okay? And the burden is on you. The answers are given to you on the test when you see it. Okay, so for you to just regurgitate what the correct answer is, you're not going to get the credit for that. You need to be explaining why your answer is the correct answer. Okay, and the burden is completely on you. You need to prove that you understand the material now. You didn't understand before, but you understand it now. So again, the burden is on you. You need to show clearly that you understand. And that's how you will earn your points back. And also any late homework for late credit for up to 50% will be available as well. But for that, you're going to have to submit them as an email attachment. Or you know what? Maybe I'll just open up all the assignments and you can turn them in. Okay, but again, you need to get them done before May 28th. And it needs to be done correctly. Okay, if you're just putting in the answers, you're not going to get anything and you're just going to annoy me. All right, so let's get into 3D shapes. Okay, so of all these 3-dimensional shapes there, tell me if you can name any of the solids. Okay, tell me in private chat any of the solids names that you recognize. And you can tell me A is this, or C is this, or H is this, or whatever else. Okay? Let's reveal. Well, the first one is called cylinder and the cone. I think we know those. Cone, just think of an ice cream cone. That's a typical ice cream cone shape. That is called rectangular pyramid. Pyramids, and this is called pentagonal pyramids. Look at the two shapes. What's common about those two pyramids? It meets at a point at the top, right? It all meets at a point, at a vertex. Okay, as opposed to regular dodecahedron. Okay, we'll talk about the name in a minute. And dodecahedron, just dodeca comes from the word 12. Okay, and it's a 3D shape with 12 sides is what this is. What else? This is called hexagonal prism and rectangular prism. They're both called prism, but one's called hexagonal prism and the other is called rectangular prism. Okay, what do you think is the same about these two, and what do you think are different about these two? Well, they both have faces that are parallel to each other. Okay, unlike pyramids, there are no faces. The bottom face, there is no face that is parallel, whereas rectangular prism, there is a face at the bottom and face at the top. Those two surfaces are parallel surfaces, as will be this hexagonal prism. The hexagon at the top of the prism and at the bottom of the prism, if you can picture it, they are parallel to each other on surface in three-dimensional points. Okay, so they are what we call prisms. What else? We know that this is a sphere, okay, like a soccer ball. This is called elliptical cylinder, and this is called torus. Now, which ones would you group together? Of all these the figures, okay, which ones would you group together? Which one do you think have some common features about them that you would choose to group together? Tell me in private chat. Well, we can group them by 3D shapes that are made completely with three edges, straight edges that have flat polygonal surfaces and sharp corners or vertices. So that those are called polyhedron. Okay, poly means many, and do you remember the word hedron that came in dodecahedron, right? Hedron just means 3D solid. So 3D shapes that are made completely with straight edges. Okay, so we have edges here, the yellow lines here, and have flat polygonal faces. Okay, so unlike a sphere, like a soccer ball, it's not flat face, right? It's all curved all the way around. We want flat polygonal faces that makes up the shape, and the sharp corners or vertices. Okay, so we should have sharp corners and vertices. Okay, so we want straight edges, sharp corners or vertices, and the faces have to be flat. And that's what we call polyhedron. And when you have 2D shape, we call that polygon. Remember hexagon, octagon, nonagon, okay, or polygon. That's 2D shape. It's flat like a paper, while it's 3D like a can of soup. Well, can of soup is not polyhedron, but like a cereal box. Okay, that would be an example of polyhedron. And okay, all right. So which ones are polyhedron from the examples that we saw? Well, remember we wanted straight edges, vertices, and flat surfaces. Which ones would that be? The answers are dodecahedron, pentagonal pyramid, and rectangular pyramid, and hexagonal pyramid, and rectangular prism. Okay, hexagonal prism, I'm sorry. Those are all polyhedrons. Okay, now I want you to think about two special polyhedron subcategories, and we talked about prisms and pyramids. And one is called triangular prism, pentagonal prism, and rectangular prism. So what's common about all these prisms? What do you think? See the purple faces? Those are what we call bases. Okay, so in this case, the base of the two faces that are parallel to each other, the bases are two surfaces that are parallel to each other, two surfaces that are parallel to each other. When we say parallel, those two surfaces will go on forever without ever crossing each other, just like parallel lines, but now we're talking about parallel surfaces. Okay, so those parallel surfaces are called the base of this polyhedron. And we always have two parallel bases and multiple parallelogram faces. Okay, so those purple ones are the bases, purple shapes in this case. And notice how the purple shape, the two parallel faces, parallel surfaces, determine the name of the prism. Okay, so in this case, the face had the shape of a triangle, so we call that triangular prism. And then the base of this was pentagon, so pentagonal prism, and the base in this case is rectangle, so it's called rectangular prism. So you can almost picture whatever the shape it was, it just being whoop, stretched out, okay, stretched out. So then each of the faces, not the purple bases, but the faces that form the side of the prism are always going to be parallelogram. What about pyramid? Okay, so pyramid will look like this. Okay, they all meet at a point, a vertex, right? So it's always pointy. All the lateral or the side faces meet at a point, and so there is only one base. Unlike the prisms, we have two bases. We only have one base, and the base again. Base is the flat side. It's not the one that is pointy. Okay, it's the flat surface opposite from the vertex or the point of the pyramid. Okay, so and the base determines the name. In this case, the base is triangle, so it's called triangular prism, a pyramid. Here, the base is square, so it's a square pyramid. Here, the base is pentagon, so it's pentagonal pyramid, and then hexagonal pyramid. And then, so you have one base and multiple triangle faces that meet at one point, apex. We call that point where they all meet, we call that point apex. So I want you to be thinking about this now. If you have a prism, okay, and we know that prisms always have two parallel bases and multiple parallelogram faces. That's what I just said. Why not say faces are rectangles? Okay, so do you see all the faces that you see here are rectangles? This is a rectangle here. This does not look like a rectangle, but when you're actually seeing it from face front on, it is a rectangle. It just does not look like rectangle from this perspective because this is a 3D shape and we're just trying to draw a 3D shape, a flat paper, if you can call it. Okay, so that's why it appears to be parallelogram, but it's really a square when you're looking right at it. Why is that? Why don't we just call that rectangles since they are rectangles? Well, that's because of these oblique prisms. Okay, these are also prisms, and prisms do not have to be always going straight up. It can be tilted to the side like this. Okay, so tilted to the side like that. And so we call the prisms that go straight up and perpendicular to the base, we call those right prisms as opposed to oblique prisms. Similarly, we have for pyramid, we said that the pyramids always have one base and multiple triangle faces. They all meet at an apex. Okay, we can have an oblique pyramid where the apex is not at the center. Okay, it's not opposite the center of the base shape. Okay, so it is more towards it's off center in this case, oblique pyramid. That's what we call oblique pyramid versus right pyramid. So what's special about the triangle faces of the right pyramid? So if I was to just focus on this, what's special about those is that they are all isosceles triangles. Unlike the oblique pyramids, they're not isosceles triangle. You can tell that they're not isosceles triangle because they are tilted to the side for one or less. Some of them may be, some of them may not be, right? So now thinking about pyramids and prisms, we limit our work with right pyramid and right prism for now, and pyramids triangles faces are isosceles and prism faces are rectangles. So what's the difference between prism and pyramid? I want you to tell me in private chat. And what is same between prism and pyramid? Okay, so between prism, what is the difference? They have Prisms have two bases, pyramid has one. What is the same between prism and pyramid?